guys, Mr. Klein here with our next lesson in our chapter on chemical properties. The last lesson we talked about physical properties of matter, and our final one will be on different types of substances. So let's go ahead and let's get started. Now, in the last lesson, like I said, we looked at physical properties, which are properties that cannot be observed without a chemical reaction. Chemical properties, on the other hand, are properties of matter that can only be observed during a chemical reaction. Okay? That's the important thing to remember. Chemical properties can only be seen during a chemical reaction. Okay? Normally, whenever we think of chemical properties and chemical reactions, we think of explosions, okay? Big boom, a fireball, you're kind of walking away all cool like while there's an explosion, okay? But not all chemical reactions are that exciting, okay? Not even for movies or anything like that. So, the question is, when can we observe chemical properties? Like I just said, it's important to remember that the only time we can observe chemical properties directly is during a chemical reaction. Now, you may wonder what exactly a chemical reaction is, okay? And you're usually thinking of explosions, but it's actually a very simple concept. Here's the definition. A chemical reaction is the process by which one substance changes into another substance, okay? So even digesting food, photosynthesis, things like that, those are all chemical reactions. Unless this is happening, one substance changing into another substance, you're not having a chemical reaction take place. As a result, you can't directly observe chemical properties. Okay? A major chemical property, the one that sets it all apart, is what we call reactivity. Reactivity is the ability of matter to combine chemically with other substances. The most famous chemical reaction we can recognize in terms of reactivity is flammability. Reactivity and flammability are both chemical properties. Flammability, like you know, is the ability to catch fire. Fire is simply a chemical reaction. So if something can catch fire, we can say it's reactive as well as flammable. Okay? What's going on right here is a chemical reaction. Heat and oxygen are combining with the fuel. Oxygen and the fuel are having a chemical reaction. Heat is being given off along with the flames. The wood is being turned into ash, gas, and other things like that. Okay? So like I said, fire is just simply a chemical reaction. So if we see something catching fire, we can say it's reactive as well as flammable. What if something can't catch fire? We'll say its chemical reactivity is non-flammable, or it's non-reactive. You try and do a chemical reaction to something, it doesn't work, we can say it's non-reactive. That is its chemical property. So here's some other important chemical properties, one of which is rust. Rusting is when oxygen reacts with iron to form a new substance, which is rust. Okay, all that red stuff on the car, that is iron reacting with oxygen in order to form rust. The rust sitting on the car is not iron. It is something else. It's ferrous oxide. Okay? So because it was one substance before, iron, now it's something different, we had a chemical reaction. Okay? So the ability of something to rust or oxidize is a chemical property. The similar property to rusting I wanted to talk about is what we call tarnishing. Tarnishing is really similar. It's when oxygen reacts with other metals to form new substances as well. Usually in a dull or splotchy pattern. If you have fine metals like silver and stuff and they're old heirlooms, they might get tarnished and they might be all splotchy and ugly looking. Sometimes though, tarnishing will come out looking much better. Like this is what we call patina. Patina is when copper reacts with oxygen in order to form this green surface. Okay, it takes about 7 years for it to happen. And what's important about a patina is it bonds really closely with the copper. As a result, it keeps the copper from falling apart. So you see things like the Statue of Liberty, or if you see statues or roofs on buildings that are covered in copper and they have that green coating, that's done on purpose by the architects and engineers because it protects the copper. So what you see right here is tarnishing. Okay, it's a chemical reaction that's taken place, and the ability of metals to tarnish is a chemical property. Okay, so how to tell the difference between physical and chemical properties? You might be asking yourself this. Well, it might seem confusing, but in reality, it's pretty simple. When we talk about physical and chemical changes, we're going to come back to this concept. So when you look at a substance, ask yourself if a chemical reaction is going on. If there is a chemical reaction going on, you can directly observe the chemical properties. If there is no chemical reaction going on, then what you are observing directly are just the physical properties. Now, for your lesson, I know you have to complete a graphic organizer, so let's go ahead and let's create one right here. Okay, we have our physical and we have our chemical properties in this T-chart. Physical properties can be seen pretty much at any time. Okay, we see its color, we can just look at it. Mass, weight, volume, density, those 4 related concepts from the last lesson, all physical properties. The color of the object, its freezing and boiling points. Pretty much anything we can observe with an object is usually its physical property. Chemical properties are a very small set of properties of matter, but they're very important. Okay, they can only be seen directly during a chemical reaction. We can view them indirectly. We can figure out some stuff about the chemicals and stuff and figure out some chemical properties. But chemical properties we talked about are reactivity, flammability, rusting, and tarnishing. Remember, reactivity is just the ability to react and form new substances. Flammability is reacting and forming fire. Explosiveness, explosions, the ability for something to explode would be another chemical property. Rusting, the conversion of iron to rust is a chemical property, as is tarnishing, when other metals kind of form that splotchy covering, or the patina with copper, it turns green. So there you go. That's your lesson on chemical properties. Remember, chemical properties, we only observe them during chemical reactions. Things like rusting and tarnishing are examples. And we can compare them with physical properties, which can be seen at any time. Those are pretty much the easy ones we most know about substances. So what we're going to do is, in our next lesson, we will talk about substances and mixtures and compounds and elements and things like that. So there you go. That's your lesson. As always, if you have any questions, please let me know, and thanks for watching.